means is, how would you say it? So if you made a structure with 1 sodium and 1 chlorine, how would you read that? How would you verbalize that? You would say 1 molecule of either sodium chloride or table salt.
You say 1 atom of sodium?
No, you would read the formula. So you would make 1 molecule. Each molecule has 1 sodium, 1 chlorine.
Yeah, so atom. So,
Yeah, but when you read it, you don't have to,
Right,
you don't have to say atoms, you just say either
a molecule of sodium and,
No,
I mean,
a
yeah.
molecule
There a
of
reason why you're doing it like that?
I'm just sodium chloride.
So 2 hydrogen atoms bond. I know.
Yeah, I'm just making sure I get the correct number of each color down.
Connected with an oxygen. You're not Googling.
One atom.
Okay, so we created, this would be
So we created a molecule of water with,
Okay, so if I would have taken it right then, this is
about
just my yellow bond.
that molecule. Do you want to show a bond?
I'm writing in the boxes, like with the water. And then it's 1 molecule of water with 2 hydrogen atoms and 1 oxygen.
What have you created? I created water. I created 1 molecule of water.
Right.
Or I created 1 molecule of hydrogen and 1 oxygen.
Well, you created 1 molecule of water with 2 hydrogen and 1 oxygen.
Like, do you want them to write it like?
We made a sticky mess.
I created 1 molecule of water, 2 hydrogen, 1 oxygen. Is that what you're saying?
Which is 2 hydrogen atoms and 1
Oxygen.
Would still be solid. No question. Did you mean only 2 or all 3 of them?
So far, they all look good.
So we have 3 of them.
So, like, you have your journal, would you have them just do their boxes reporting out in the journal? And then this would be what you would do.
Okay, so I think that since
Do it again.
Is that the word that
Oh, really?
So you want us to list all of these?
Oh, okay. You'll have to go and see. I was getting a little crazy with Jesus.
That's not all we have.
So what would you call this mixture?
You say water, and then write H2O.
Just like you.
Oh, well, I labeled the boxes, so.
Either way, it's not solution.
Okay.
Okay.
Would it be clarification?
create two.
Yeah.
I'm gonna fake
We,
molecules of.
this procedure.
Watch it.
I'm so sorry.
Especially like the 5 boxes of labels.
When they start getting there, they start having.
Two molecules.
Sometimes I think
Better way.
it was like
I remember the dad job at
So you should have 2 molecules and 3 of water and 3 molecules of sodium or salt.
It's the right balance.
We need 2 more. Because we created 1 to begin with. I'm making that correct.
And then this has to be clear right here.
The green and the purple. We need 1 more purple.
We have green, we have.
Walking around.
Hey, I wasn't, we were gonna happen, so you can't blame that on me.
No.
No, because it says 1 more oxygen and 2 more. And if we have that together.
So I'm off
So I created 2 molecules of water. Right? 3 molecules
Tables.
I never looked back.
Okay, guys, it is 8:45. Are you about done with this?
2 more questions.
2 more questions.
Very short.
Okay, reporters, can I get your attention while other people work on the questions? Reporters. I have some edits that I've made along the way. Would y'all tell me the edits you have in addition to these? I have the addition of a supplies list. Reporters, what is an adequate number of gumdrops and toothpicks?
A lot.
A lot. Okay.
I think a bag per group.
1 whole bag.
Yeah.
I say I think the bag,
2.5 per class.
Was that enough for all
at
of
least
us?
3 bags per class.
Because there wasn't enough white subword.
So a half bag per group. Toothpicks. No, I mean per group. What do you need per group? Yes, ma'am.
Since we did have to cut it, should we supply them with also plastic knives as well?
Yes, that's a great idea.
Excuse me, I have a question. 1 bag per group of how many students?
4.
We had 4.
Laura, might I suggest Skittles?
Yes, okay, all right.
Just a thought.
Baby starters and colors.
Yeah.
No.
That's 6 colors.
I like
Okay.
marshmallows. 6 colors.
We did
marshmallows.
Yeah, marshmallows. Okay.
But you don't have enough.
Except they're not colored.
Okay, now, I have an edit here.
The 2 needs to be a subscript.
Yes, that's what I did. Was there another one?
Not that subscript.
Okay.
You could get 20, like, extra.
Page 2, any edits on page 2?
Aspirin needs to be tacked on.
Oh, you're right.
On the construction little paragraph, saying like you must like keep all 5 because we weren't sure if you wanted us to build one and take it apart to build the other.
Okay, how would you say that?
Keep all models intact. Until the end of the investigation. They did go back and steal.
Or by the end of the investigation, you should have 5 constructed models.
Well, by the end of the investigation, you're gonna have more than these.
Oh, okay, so.
I'll just say
Keep all your
them-
models.
Yeah. Okay,
And then it's
3, Tim suggested move this
Christie,
the,
number
to
one.
the, before the connection section. And then provide an example of what is expected about writing.
Kids probably don't know what intent means.
Well, I'll rephrase it.
But I mean, like, for play purposes, like, we all know that, but.
Yeah.
How would you write what you created using scientific terms?
1 molecule of table salt.
Yeah, but
Whatever you create.
write that in there.
Yes,
Yeah,
I'll say 1 molecule of,
Does that go back to what we were talking about on the first page of labeling?
yes.
Because I suggested that with this one arrow here, the big arrow that Laura tried to draw, or edit or whatever, that looks like it could be this whole molecule. So what I suggested was, of course, add that one arrow there, but have the students label a blue one, a white one, and a red one as an atom, so that they know each one of those is an atom. And then I circled the whole molecule and labeled that as an atom. So,
You mean
As a
molecule?
molecule.
I'm sorry, molecule, yes. I had it written that way, I just didn't say it that way. So maybe that might address this issue here up front.
Yeah, maybe up here we could say pictured is 1 molecule of whatever this is. So that the verbiage is there, modeling how you would read this image.
On the page 3, on number 3, let's see, 1 more each.
Wait a minute, have we finished 2 though?
No, we haven't, yes, we finished number 2.
So is 2 though where you're suggesting about,
Give an
The-
example of how to read, how to write it.
yes,
Okay, where you say make 1 more H2O molecule, and should it be 2 more NaCl?
Sure.
Oh, yeah, we've already made 1.
Okay,
Okay.
and then which would make this on number 5, making NaCl molecules. Any other edits?
Because we already had 1.
Okay, let's look at what you did.
So, what we had,
This is 23 atoms create 1 molecule.
and then and then 1 CO. And then I had to make 2 more, so now I have 3.
We didn't find those. Okay, on your paper, and I loved, guys, I loved watching some of y'all do this. I think this is a great idea. Listen, please. Thank you. All right, Pam, I saw your paper where you folded it into 6ths, and can I use that? Thanks. So I love how Pam did this. She wrote her name and the name of this activity. She labeled each of the 6 sections, the other 5 sections with the chemical formula, the name of it, what you call it, and then drew the chemical structures that she created and colored them, complete with what appears to be whiteout for the white atoms. That's really nice. Don't give her a hand. Now, Pam, I'm gonna put you on the spot. Why did you choose to create them this way? Like, for example, rubbing alcohol. And maybe your whole group did them. Why did you choose to create it that way?
Well, Mrs. Gomez was explaining to us that hydrogen can only have 1 connected to it and can only bond with 1, and the oxygen can have. She was kind of telling me, refreshing my memory on chemistry, which I haven't done since high school.
Okay. So y'all you kind of had some ideas about how things were connected?
Yeah.
Okay, yes?
So I let them put together rubbing alcohol the way they wanted. And then when I got to acetone, I said, so think about it like this. if carbon can only bond to 4, hydrogen can only bond to 1, and let's say in this scenario, oxygen is 1 to 2.
Okay.
How
So-
would you problem solve that one?
So
they're gonna make-
you have a lot of knowledge that the rest of us do not have,
Yeah.
right?
Let me clarify.
We're all over here going blah, 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 blah. We hear words coming out of your mouth and no. So you have that background to know how those should be connected. So if you weren't there, Pam, how would you have put it together?
I would put it together so that it looks pretty.
Okay, okay.
That's what I probably would do.
So, what did you use to connect each of those gumdrops, each of those atoms?
Toothpicks,
And what did those toothpicks represent?
bonding,
Which is,
joining them together,
okay,
the atoms together.
so you joined each of the atoms together with a toothpick.
Yes.
Okay, all right, cool. This looks really nice. Yes, ma'am?
Would it be incorrect to tell the students or let them bond it their own way and then have one problem, just one? So in this scenario, let's say 4, 3, like tell them they can bond and then have them try to problem solve it, just one of them. You're not telling them this is how it happens in just this scenario, so they can at least be exposed to it one time and view it like a little puzzle.
You could, but we have not given, at this point, you don't have the tools to problem solve. We have not talked about subatomic particles. We haven't talked about what those subatomic particles are, what they do. They're just atoms that are connected together. And you'll notice that in our handout, part of the editing is that we removed references to bonding, because that is not an 8th grade standard in the national
think
standards.
What she's saying is like, your hydrogen can only have 3 toothpicks in it.
Yes,
Your
why?
oxygen,
Do you really wanna get into that before
Tim,
the grade level?
So on the first page, you removed that chemical bond right there?
Yes,
Because I didn't, did you? Okay,
And it should just read, these atoms are connected to one another.
yes,
okay.
right.
And then on the third, the next paragraph, you actually change it bonded to the word connected in that last sentence.
Okay.
Okay, let's go to our questions.
Laura,
Yes,
did
ma'am.
somebody answer your question? You said why?
No, I wasn't asking why
I need
literally.
to know why.
Because we haven't learned about subatomic particles, which means we haven't learned about valence
I think the question was,
electrons.
it can only be connected to one.
Yes.
So it's a short little 5-word thing, why? I just need to know.
Oh, she means, for her own knowledge, she wants to know
Oh,
why
for
the
your
hydrogen.
Okay, go.
Explain, Renee, go.
In one sentence,
5 words or less. That's the way it is, it's the rule.
I made it so.
I have a better one for that. When I took organic chemistry, and you know how the electrons are very orderly near the nucleus, and then they start going all these different ways. And so somebody in the class said, what was your name? Fan, Dr. Fan. She was from mainland China, strict Baptist. So he said, Dr. Fan, why does that happen that way? And she said, I don't know, God made it so. So, a version of yours.
Yeah, it's the very simplistic version is if you were to do this, you just give a quick little chart. Oxygen, hydrogen. But if you get it wide, it'd be a whole extension, but very simplistic, that's the rule.
But I can't learn something if I don't know why.
has to do with the valence.
Yeah, that's like how many they can share and where they can bond.
It's
So
more than 5.
it's more than a 5.
It's like 2 college courses.
I'll talk to her on the way home. I'll be, you know, one of the things I was thinking about was, how many hands do you have? You only have 2, so you can only make 2 connections. So an atom has a certain number of connections, each atom has a different number of connections. So I think I might explain it kind of simply like that.
So it's the makeup of the atom.
So if you have a one big electron, you can bond to one other person.
So this is probably not connected.
Okay, when you made your structures, each of your structures, y'all chose 5 of them. Would you, on your paper, label label them, is it a compound or an element? On your paper, on your 5 structures.
Do you remember?
You made 5 of them? On the 5 you
This
made.
one is the compound. This one is the element. And the rest are compound. Right? This is the element.
Okay, 5, 4, 3, 2, 1. Now, you labeled all 5 of the creations. Your molecules, you've labeled them either as an element or a compound. And Melissa, what did you label yours as?
So we created,
May I show your picture of what you guys made?
yes,
Okay, Rochelle, would you, well, is it on? I'll get it on when you bring your picture.
we need our efficiency element.
Oh, you got certain planning? Okay, so, as you can see, we made a model of water, carbon dioxide, oxygen, and sodium chloride. And the only element that we have was oxygen, the other 3 are compounds.
And how did you make that decision?
Because I only had 2 atoms of oxygen to create the element like oxygen.
Okay,
And,
or whereas on the other 3.
oh,
you
whereas on
labeled
the other
compounds.
ones, there are more than 1 atom of an element
Are they the same?
included.
Are they the same?
No, they're not same, because water has 2 orange and a red.
Okay.
Carbon dioxide, 2 red and a purple. So they're
Yes.
different elements that are put together to create that compound.
And oxygen are
The
the
same.
same.
Okay, do y'all understand what Melissa said?
Yes.
Any questions? Okay, thank you. Did anyone come up, are there any more elements on your list? Was there another one?
It was chlorine.
Yeah.
So if you look at your list here with your chemical formulas, you can see that each chemical formula, this one has 2 types of atoms, 2 types of atoms, 2 types of atoms. Now look at this and be careful. You just count those uppercase letters because chemical symbols can have 2 letters associated with them. And the first one is capitalized, the second letter is lowercase. So we have NaCl, that's sodium and chlorine, that's 2 elements. Oxygen, Melissa said, was an element because it contains only 1 type of atom. NH3, that's 1 nitrogen and 3 hydrogen. That's 2 types of elements, so it's a compound. This compound contains 3 types of atoms. Aspirin has 3 types of atoms. And look at this, rubbing alcohol and aspirin, all composed of carbon, hydrogen, and oxygen, but in different ratios, which makes one of them rubbing alcohol and one of them aspirin. One of them is healthy to consume, the other one not as much. Hydrogen peroxide is 2 hydrogens, 2 oxygens. Acetone. Now look at acetone, look at that compound. What do you think? It means that there's carbon, 3 hydrogen, another carbon, an oxygen, another carbon, and 8 hydrogens. What does that, do you think that's intentional that it's that way?
Yes.
What do you think that might tell a chemist? Go ahead.
So that carbon is bonded to 3 hydrogen, then that carbon is also bonded to that carbon, then the carbon is bonded to the oxygen, then the carbon, I can't feel like I draw arrows.
Okay, So it's kind of like there's little molecules that make up the big molecule.
So, are you saying then that if you put those letters in a different order, but the same amounts, you wouldn't have acetone? Is that what you're saying?
Renee. Sorry,
I was wondering if you put those same atoms in a different order, but had exactly the same atoms, it wouldn't be acetone anymore. Is that
No,
what
it
you're
wouldn't
saying?
be, but yes, it would be something else.
So I could put OCH3CHC. I could rearrange those
It'd be something else.
and it would no longer be acetone, even if I had them in the same amounts.
Yes. For example, since for rubbing alcohol, you need an OH bonded to each other to be an alcohol.
Okay.
So if I were to change, this is acetone's a big one, so it's easier for me to talk about rubbing alcohol.
Okay.
If I were to change that O and bond it to no hydrogens, then it wouldn't be alcohol.
Okay.
It'd be something totally different.
Okay.
It's, I think,
So it's
in
basically
simple
that
terms,
recipe, and you have to have it that way, or you do
Yeah,
not have
it
that.
tells you
Yeah.
about how it's structured.
It's kinda like
Okay.
coal, charcoal, and a diamond are all carbon, but they're
Right.
structured differently.
Right.
And we're gonna talk about that actually a little bit. Then we have caffeine, which contains 4 different atoms, 4 different types of atoms. And then chlorine is the only other element besides oxygen.
That's it.
Because it contains 2 atoms of exactly the same type.
Just looking at your list, I was thinking you maybe might wanna consider